Hey, hi. Good morning.
Yeah, hi. Yeah, good morning. Hey, thanks for joining the call.
Sure.
Let's start some brief introduction. I'm having around 10 plus years of experience in software industry. So I have worked in Java, C++, Python, Spring Boot. Currently, I'm working on designing highly skilled systems. So working as architect. So that's all about me. Would you like to introduce yourself?
Yeah, sure. I studied three in Queens. It's been 3 years for me here. And I work on Kotlin Java with Spring Boot and a little bit of Python and Celery for all the asynchronous thing. And we heavily rely on AWS as a cloud stack. And yeah, and I work for the logistics vertical in this e-commerce company. So Quince is actually an e-commerce company where it can be considered like a Meesho for US customers, but then we sell luxury products at affordable prices. So that's our USP.
Okay.
Yeah, so that's pretty much about what I do.
I just posted the questions. Okay. So you need to come up with the solution. Looking for is we are looking for uh, let's suppose a tweet service, right? Whether user should be able to post the tweet,
Yeah.
and what would happen like once a tweet is done, its a follower should get the update, not update like they should be able to see the post on their home timeline. Okay, based
Mm.
upon some sorting. Apart from that, just consider two use case. One is the normal user, the other one is a celebrity. So how will happen? And
Okay.
the first part is like the service should be highly scalable. How will you do it? Reliable, fault tolerant, caching. Where would you using? How would you authorize the service? So authorize the service part you need to focus more. And that store post history. How other people will not get notification about your tweet. Okay. And the DB selection. What DB selection you would be using to store the data and disaster recovery and error management. And the other part is like write down the high level API in their
Understood.
contract. Okay.
Understood. So,
So
so the yeah.
yeah,
So the high-level API contract is for the authentication authorization and also how. So I mean, okay, I think maybe I'll just list it down, and um, yeah. So okay, so looks like there is a whiteboard as well, right? So I might need to use it for the HLD components, right?
yep.
Okay. Sure. Okay. So first, okay. Because I think because we are talking about a highly scalable system, or a highly scalable application, let me just come up with what can be the numbers that we have and what kind of RPS that we are trying to achieve in this and all of that. So I think because it's like a Twitter kind of service, can we assume that we have like, let's say, I mean, Twitter usually has around probably a billion, but
Mhm.
if I have to take daily active users, probably it's let's say 20%, which is or 200 million. Can I assume this as the daily active users?
Yeah, yeah.
Okay, and so yeah, and then these are the active users, and then let's say they do this is a Twitter post service, so we need to post. I mean, do a post on Twitter. So assuming let's say two posts per day uh, per user,
Mhm.
or should I have or I mean two to three or let's say three posts, and then because I think Twitter also has some video sometimes some links hyperlinks and I think some video content and things like that, so we can assume let's say 1 MB 1 MB is too much, or let's say 500 KB on an average per tweet, right? So this becomes so this becomes um, so this becomes uh, 200 million, which is 200 into 1 million is 10 lakhs, which is this 1, 2, 3, 4, 5. And then, okay, for the sake of, I'll just assume 1 MB for the sake of easy calculation. So 1 MB per tweet, and we are doing 3 tweets per day, right? Per user. Then, so yeah, I think this is, okay, I forgot the MB part, which is 1 MB is like 1000 KB, right? Um, okay, so the data calculation, I'll keep it aside, but, and if I look at, so this is per day. And if I, okay, so 200 into 200 million is 10 lakhs, and then into 3 posts uh, per user. So this is per day. If I have to, so this is how much, 2 into, so it is actually 6 into 10 raised to the power of 1, 2, 3, 4, 5, 6, 7, 7. And then, so let's assume per day it's like, I think it's 86,400, which is 400, which is like 100K, which is 10 raised to 5, 10 raised to 5, which is coming to 100. Okay, on an average, we are getting 100 RPS. I think for a Twitter like application, this sounds less, but I think usually 200 million, 1 million is 10 lakhs. Did I, Acha, okay, I think, okay, this is correct, 10 raised to
Yeah,
5. Okay, I think maybe, I mean, definitely it's not 100, but usually it can be even like 1000 RPS, because 100 RPS is
yeah,
nothing.
more than 1,000. Like it's
Yeah.
around 30,000 or something.
Yeah. So, yeah. So
I
we
mean
can,
that's fine, no problem. You can do some calculation for okay, RPS. Got it.
yeah.
Okay.
So we are assuming that 30,000 RPS, right? Which means this is like very heavy, highly scalable system that we need to build. And definitely, I think the read versus write ratio must be definitely something like, the reads are very much heavy. So I'm just assuming 10 is to 1, because not that every, I mean, for a Twitter like application, people tend to read more than post more, because only those celebrities and all post usually, assuming. And so if I have to even look at the data as well, so basically if I look at the data that we need to have stored per day, this is 200 into 3 into, okay, so here comes the MB part, which is, okay, into 1 MB, 1 MB, which is equivalent to 200 users, 200 billion into 3 into 1 MB per day. So this is like 6 into 1, 2, 3, 8, 6 into 10 raised to 8, which must be like, um, which, I mean, this probably would be around, let's say 1 TB. I mean, if this is RPS, maybe we can assume uh, per day 1 TB or something like that, right? Which means again this is also very much high. Um, okay. All right. So I think, so now I think, I'll so we are talking about authentication and authorization, right? Authentication and authorization. So I think as part of the authentication, we should have. So I just write the as you asked for the, API layer, right? So let's say we have API slash v1 slash, because we need to version our APIs. Let's say we have a v1. Let's say we have a sign up thing, sign up as an API, and then we have v1 and slash login. And again, there will be different mechanisms here. Um, so this can be username plus password based. Sorry, password based, or mobile plus OTP based. Let's say we'll assume only these two. So here, if I have to come up with the contract of the sign up, basically I'll just write a JSON. So this will be like a post API with a sign up option. So we have things like, when yeah, first would be an email, I'll just email which is of this and email, and then we have optional phone number which can be associated if they need phone number, and and while we register password password, and we usually, let's say, have a because we generally want to do a what is this we want to do a re-enter, so re-enter, so basically this will be used for our calculation. uh, Confirm password, let's say, confirm password, and so I think the authentication, I mean the sign up will have, I think this should be good enough, and then email based password, and I mean based on basically we can also have a sign up type as well, sign up type which will be an enum to support username or password based, or mobile number OTP based. Only then few of the things will be option and all. So this is what the sign up API would look like, and obviously for the login, um, we'll say based on the type we'll have a username and a password, username and a password. um, so do I have to even write the like schema of how this will be stored uh, in this? Hello, hello.
Yeah, go ahead. I'm here. Yeah.
Okay. So I was asking whether I need to write the schema, DB schema and all for these,
Yeah,
how they would be stored.
correct, correct. Like this is the expectation, right? I mean, I just wanted to understand like how basically query will work basically, how to just to fetch the data using these
Right.
schemas, right?
So
Well,
here is where I think we will move to, the high level component. So basically,
yeah, yeah,
because this is, yeah, yeah. So because this is a very big, highly scalable system, we need to have at different layers at different things. So basically, we have an authentication system, authentication service, let's say. So I think I'll use this blackboard, whiteboard. Sorry. Uh, where is this? Huh. So we have a sorry. So we have,
so Dilip, I mean, you can take your time. I mean, let's 10:16 is there. We'll meet at 10:25 around something.
oh,
And
sure. So basically, I need to draw the component in those times. I mean, in that time, and then also come up with what DB selection that I would. I'll just
correct,
write
yeah,
it here, and then after that, we'll explain, right?
yeah, yeah. And just focus on the 6 point also, like how user will be able to see the person post which they are following, right? So
Right.
it could be normal user or celebrity. Then how would you use the caching and all? Okay, just focus
And
on that also. Till then, I will be back in 5 minutes, man. Okay,
sure, sure.
okay.
Yeah. So let me draw the component. Components, and then we have, so then I have a authentication service. I need to draw a diagram. Authentication service. Then let's say I have an authentication service. Then I think First, let's assume that I have an authentication service. Then I have a user service. How do I structure it? And then we have a let me have user service, and then there will be a news feed service, Twitter feed. Let's say I have a Twitter feed. I think for the feed and all, we have to have another service, and then let me also have a tweet service. So basically, tweet post, tweet post service, and so we if we have load balancer, then um, first let's I mean, and all of the static content should be stored with a CDN. Should I just put a CDN? Okay, so client will directly do, I think, web mobile, and then this will, let me just draw connections. Web and mobile load will have load balancer. It will talk to the authentication service load balancer. From load balancer, from the do we need an authentication service in this? I think um, so. This is a user service. Do you have so where will we have cache here? Um, the users active users can be in the cache. So let's say I have uh, cache, and then this same thing can also be used in the cache here as well. Uh, then what else will we have? So we can have between the feed and all, feed and then the tweet service can directly, I mean, that can also drive the traffic to the uh, load balances. And then okay, and then let's say we have queue mechanism to, if there is a Twitter from Twitter post, uh, let's say I have a message queue for something to once the post is um, once the post is done, it will be done, and then it will be published to the feed. So this would be the direction, and this will populate the feed service, and then authentication will have this. In fact, I mean, user service, I don't need this actually. Oh, damn. Oh, damn. Um, Now I think let me also then let me go to the table structure of this to handle this. So let's say we have, so as table selection, okay, database selection will be SQL to handle user management. For posts, we can have SQL DB like I think we can choose Postgres or even MySQL to handle management as it as it needs to be ACID compliant. And for posts, Twitter posts, we can use a NoSQL DB, um, like Cassandra, as that there exists no relation between posts. And uh, if there is a okay, so now let me structure the tables as well. Hello.
Am I audible? Am I audible?
Yes, yes. I hello.
Yeah, yeah. Go ahead, Dilip.
Yeah. Yeah. So for the DB schema, so basically, I mean, I'm getting some disturbance. Okay, now it's good. So what I'm trying to say is that, um, okay. So coming to that, so let me just explain what I have drawn here. So basically, clients, it could be from web, it could be mobile, or it could be, yeah, I think mostly these two. For it, are you able to see my screen? I mean, the whiteboard.
Yes, yes.
Yeah, so basically, we will have a load balancer. So this can be a combination of a network load balancer or or at an application level load balancer. So in AWS terms, we call it ELB. So it can be even an NLB, a combination of NNB plus ELB or just ELB. So that's more about the infra part, but definitely we need load balancer so that we can use the proper number of nodes available, and then based on the algorithm like round robin or even least frequently used connections as a algorithm there. So from the load balances that we have, to ensure that the user authentication is taken care of, let's assume that we have a user service where it will have a record of all the users, and especially and there is a cache for the daily active users, because user profile has details like use like profile pic, and then some data, and then some bio and stuff like that. So all the active users profile information can be put in cache. However, there is a DB as well. So here, I mentioned that we can use a combination of two things, especially to handle user management. We can have we can choose a MySQL, a SQL based databases, because we need to be very much ACID compliant in this case. Because we also talked about, I think, the disaster recovery and error management. So SQL works like a charm here, because it one of the properties is the D of the ACID is the durability, right? And also, I mean, definitely when we choose SQL, we can have in order to have the to handle disaster recovery, we can have, I mean, the way we generally do is make choose something that is asset compliant. And uh, and also, so let's say we have a multiple regions, replication at multiple regions, or availability zones, as we call it, availability zones. So that's what um, so that's how we can handle. And because SQL databases use write ahead logs to handle the durability, it's very easy to to recover when such things happen. And I think that there are some other strategies as well, where we wanted to do multi-cluster, database clusters instead of a single instance, where we can have availability groups as well, usually, um, to handle such things. So that's how we can handle the disaster recovery. And I also mentioned that we can use NoSQL databases like Cassandra, because the feed, the post that we're gonna do usually do not have relation with any other feed of any other customer, or any other user. And then because we are talking about a highly scalable thing, using a NoSQL databases makes it easily horizontally scalable. So that's why I have chose this, because definitely we need not establish any relations. However, usually, I mean, a big platform like even Facebook uses, I mean, so it leverages on the existing MySQL SQL database only, but then they kind of do their customization. So similarly, we can either do that, or given that we have a good amount of good support for the NoSQL databases like Cassandra or MongoDB, we can very well go with that as well. So it's a mix of both for a post and all, because the post will also have links, and and things like that. So now I'll quickly show the interaction of these different components. So once the user management, authorization and all will be taken care of here. So now if so
What is
actually
the
I need to
use
have.
of cache here in user service?
Yeah, so because we are talking about 1 billion users, right? And it's always good to maintain the cache of daily active users, so that because for example, when I post a tweet, all my followers or all my friends or followers should be aware of it. So if I maintain that cache in this followers itself, then sorry, in this cache itself, then it's easy for me to push it to their feed, and things like that. So so
Okay.
that's like, so whatever the 200 million active users that I said, I mean, it's not like even though they are daily active users, the cache can have details to expire and store only a limited set of it. So this cache is to maintain daily active users out of 1 billion, let's say 1
Okay.
billion users all.
But I
And
think one more thing you missed it, like to write the API signature of post the tweet.
yeah, I'll come there. So I just wanted to tell whatever I wanted. I will be doing that.
Okay.
Um, and then yeah, so whatever feeds that are posted, that will be handled by this service, for which I will write the APIs. Right, and then okay, so once after writing the APIs for tweet and all, I'll come to how we can solve the how followers are notified of a post done by a normal person versus someone like a celebrity. So now the let's go to the API contract of a tweet, right? So let's say basically we talked about a Twitter post service, right? So I'm just taking the first service as the base thing, and then let's say I have an API like this. Let's say tweet, right? So tweet, this will the signature can look like, so basically a um, user ID, which is the unique ID associated for a user. user ID, and then we can have a tweet ID. This will be generated on the backend service, but let's, for the sake of this, we can assume some random UUID kind of UUID, and then we have a tweet text. So this will have, definitely, I think always tweets have some max. Uh, it's a string with max limit of, let's say, I think Twitter is like 140 characters, or let's say 200 characters for our use case, right? And then we have it, and then we have this. Then we have and then we have links, any extra links, or any. So basically, here I mean as extra. So I forgot one more thing. Where, for example, um, like, so I think we should have something like a media service as well, to handle all the file content, um, store file media storage service. um, so this can be a blob, or in fact, because we are using something like a NoSQL here, um, uh, I think that supports even JSON columns and all. I mean, we can always put JSON because that itself is a JSON. So we can store all of the things here, and this can be published through CDN, because these are all static ones. These are all static ones. Um, Once they are uploaded, and also in the cases where someone want to share a tweet or retweet, as we call it, the same thing can be used. But because we have not discussed about, because retweet is not even in the scope, I'll not talk about it now. Coming to the yeah, so here it could be an array of uh, the storage links. So I'm just media storage links. Basically, we give an upload option kind of thing, right? And then it generates, let's say, tiny URLs. I mean, we can also use that, or because the user doesn't see, we need not talk about this here at the moment. Media storage links, which can be, for example, or S3 link, or S3, or any other blob storage link. So I think, so this is what else can we have? So I think we have, in order to have, I think the audit fields and all can be handled at the data layer. So yeah, I think to add a tweet, we can have basically a user ID, and I think this is good enough. Text and tweet ID, and probably if you want to add some tags to the tweet, hashtags and all, we can do that. So this can be an array of thing. So it could be something like
Yeah, just
hash inter.
new information I want to know,
Yeah,
Dilip. So let's suppose I posted something.
yeah.
This part actually I want to understand in detail. If you can explain more detail.
Yeah. So,
Okay,
right.
let's suppose I am following you and Narendra Modi.
Yeah,
Okay, you
right,
you
right,
you posted something, and when I will open my Twitter, I'll should get a post related to you, as per your the time, like
right.
posted created time, right? As the same as the Modi ji has also posted something, I also should get the. So, but the behavior is different, right? Performance wise.
Exactly.
So
Right, right.
that's what I
So,
want
yeah,
to understand in detail. Like,
sure, sure. So, I think, okay, so celebrity versus non-celebrity. I think, yeah, I think, let me come to my thing here. So, as you see here, when a tweet is posted, sorry, when a tweet is posted, uh, and then I mean, we also, because in the user service, we also have, so we can also maintain what are the user followers for a given user and all. So we can publish all these. So once a tweet is posted, we can push these events to a messaging queue kind of thing here, like a Kafka or even SNS, SQS of AWS. So we can push these events so that they can, and then there will be consumers listening in the we will maintain a Twitter feed service separately, in order to deal with the feed of a particular user. So this is just for the adding or tweaking the post and all. But let's say I send it to a Kafka topic, and then I consume here. However, when we do the feed for a, because a celebrity will have n number of followers, and then it will be very much right heavy if I have to add to the Twitter feeds, to the timeline of that particular user's followers. So what we can kind of do is like a so we can do a hybrid approach where for those who do not have many number of followers, we can do a real time push. So it's like a so basically it's like a push versus pull kind of mechanism. So let me write it here to handle celebrity celebrity versus non-celebrity. Um,
Sorry, go ahead.
Yeah, so I was saying that because there will be a huge number of followers for a celebrity, and if we just publish in real time, then it will be a lot of write operations. It becomes write heavy on the Twitter feed service, and then again we have to scale up the Kafka topics and then the brokers and all. So what we can do is for celebrities, we can do a pull, meaning a pull based mechanism, meaning whenever a celebrity posts a tweet, then the user, the followers feed, it will be they will get the feed appearing on their timeline only when they reload it. So and then for those with less number of followers, we can do a fan out here, or meaning we can simply do send it to the Kafka broker, and then push in real time so that it gets updated in their newsfeed. So this way, I mean, it's like a mixed model that we choose. So basically, we should have a threshold to decide who. I mean, we need to have different thresholds to decide whether we should do a pull versus push or things like that. And also, I think it can be based on several other factors like so it could be like the usage of the usage of the follower, I mean the active he being active or not, and then relevance, and then something like even geographical factors. So we can for celebrity tweets, fan out or push for um, non-celebrity, for users with less number of followers. Yeah, I think yeah, I think this is how we can solve it. But when it is a push model, we can use this Kafka implement. I mean, it should, even though it is almost real time or near real time, we can choose a messaging queue instead of directly hitting the APIs because it can fail. And yeah, so that's how we can solve it.
Yeah, one more thing I want to know. You are using the messaging queue. Let's suppose
Right.
I posted something, right? I
Yeah.
posted something. Immediately, I will be sending to the Kafka for the
Right.
user.
Right. So that's what in this diagram. Based on whether it's a celebrity or not, we will as soon as it is posted, we will push it to Kafka. Yes, and then and also there is a cache, so we can maintain. So here also there is a cache, right? So again, yeah, for your question, I think yes, we need to push it to Kafka, and then for with less number of followers, and then uh, also put it in the cache feed for all the because it will be appearing for all the user followers timeline. But yeah, it will be as but it's done in an asynchronous way, uh, not like API hits and all.
Are you storing in persistent data store somewhere?
Yeah, so the Twitter feed it will be. I mean, even though it has a cache, it also has a DB as well. So here it's the persistent storage because we need to essentially save a post, and then the same thing will be sent. The same event will be sent, which will be consumed, and then even the feed can also maintain its own database because we need to maintain that separation of concern. However, we have put it in the cache because the same thing, the same content of the tweet can be used, will be published in all the timelines of the followers, right? So that's why there is a feed as well here. cache as well here. Hello.
Yeah, yeah, I got it. I got it.
Yeah.
Then how would you handle the disaster recovery? Sorry, before that, can you help me to understand how will you scale the system?
Right. So, because we are, because we need to, it's easy for us to do horizontally scaling. The way one would generally do is, uh, so basically, whatever scaling is needed at different levels, right? It could be even at a, yeah, for example, even at a Twitter feed service and Twitter post service, or it could be anything. So, sorry. Um, Let me go to the right. Yeah. So, scalability wise. So based on different metrics like average CPU utilization and memory, we can have alerts triggered, which can be configured with auto scaling policies. Meaning, we can have like min replicas. For example, if we use a completely proprietary like EKS or anything managed service, we can have a min replicas and max replicas defined, and then the auto scaling happens. Um, Upscaling happens. Upscaling and downscaling um, happens via auto scaling policies that I mentioned. So yeah, so it's usually based on CPU utilization and memory for for services with synchronous system. For services with asynchronous, then we can for upscaling event-driven systems. Basically, event-driven systems, uh, we can use metrics like um, queue message delay and then uh, um, average time spent to process a queue message. So we can put different metrics. So even in our case, we have different auto scaling policies configured based on different metrics, based on whether the system is event driven or a synchronous kind of system. Yeah, and then again, yeah, I think we can employ a horizontally auto scaling policies. So the thing is, so here in the Twitter feed service, because we have anyways chosen a NoSQL database and things like that. So so scaling at different levels is there, right? So we scaling at even a service or even scaling at a DB. When it comes to DB, if you choose a SQL database, we can only vertically scale. But because if we have chosen NoSQL database for some of the use cases, it can even horizontally scale because we can use different partition techniques to decide which the data should go to which node, and then we can have the leader follower replication strategy and maintain the read replicas and all of that. But now it comes to the service level, it can be based on these different metrics, and then we can have health checks defined, and then health checks defined, and we can have so I mean the the health that for something like actuator can be used in case of Spring Boot. So once if any of the healthy pods become unhealthy, then we need to do the upscaling as well. Yeah.
Great. And any idea how do you handle the disaster recovery?
Right. So disaster recovery. So first thing is for for see, so this disaster recovery is for databases. Are we talking about?
Yeah, always. Yeah.
Yeah. As I said, like SQL comes with these properties of ACID. However, so we can have a primary and a read replica and things like that. So we can use the patterns like change data capture CDC to replicate whenever something goes wrong. By design itself, SQL tables, SQL databases follow this ACID property. So now with coming to NoSQL databases, the idea is that um, NoSQL would be usually we can maintain eventual consistency when it comes to the recovery management. So here also, I mean, as I said, uh, replication strategies can be used. Strategies, it could be across, the replication can be done across different regions or zones, and then so I think these are, and then again having standard SOPs on how to, we can also put SOPs on how, uh, I mean that's all probably for the documentation and all, but usually we have to do the replication and all of that. So even so the
Let's
replication can be done at, yeah.
I'm in Mumbai and database also there in Mumbai. I made some requests, some data change is happening, right? Data update is happening. Immediately disaster happened. What will
Right.
happen in this case?
Yeah, so even when it comes to database and all, because it's a server, we will be monitoring the health checks. You know, if that goes down, we can definitely move the traffic to another, as I said, availability zone, right? So, for example, Mumbai is one availability zone. The other could be it could be Delhi or something. So we can redirect the traffic to there, and then because we maintain we can even maintain a replica kind of thing, not like must leader follower kind of thing. Uh, so the way we, so at the time we know, because the pod is healthy, we can move it to a different multiple availability zone, geographically located somewhere else, much far. uh, and then also I mean our the replication clusters, not clusters. I mean when you maintain a group of, when we do the cluster management, it's much more easy. But even otherwise, we have to rely on the replication strategies, like whatever we have replicated for databases and caches, and especially write ahead logs in case of SQL. We would be able to back up and restore whatever that's lost.
Okay. I
Yeah.
think I'm good with the interview here.
Okay.
Any question for me, Dilip, that I can help? I think I'm pretty much okay with this round also.